for condensation, we have three types. One type is surface condensation. So you have a cold surface, it condenses, also known as bathroom mirror. So then you have homogeneous condensation, and that is when you have the condensation essentially in the middle of nowhere. That's the case of a morning fog, right, in which the water condenses in the form of little droplets. But it's not necessarily on a surface. It just it can nucleate the liquid from the vapor. Right? And by the way, about homogeneous condensation, some people argue that you need so much energy, right? And it would be so thermodynamically not favorable to nucleate liquid out of nothing that typically you'd have some sort of a seed, some contamination in the air that helps this water form. And I don't know about the morning fog, but have you ever heard about cloud seeding? Right? So in some places, you might want to make rain, and actually you have somewhat of a chance. If you have enough moisture in the air, you can make dispersed elements in the atmosphere that would make the nucleation from vapor to liquid more favorable. And then you can create a cloud and hopefully some rain. Right? Isn't that interesting? So they would send a rocket and explodes this thing that has this very fine dust, right? That acts as a nucleating agent. And then you have direct contact condensation. And that is when the liquid condenses, the vapor condenses on its own liquid. When we talked about subcooled boiling, right? The whatever bubble you generate, the vapor then goes back into the liquid. Or for example, you can make some vapor condense by having a spray of cold liquid that would make the vapor condense onto its own liquid. Right? We have these three different ways. So let's talk about condensation, the one on the mirror. Right? And this is the one when you buy these products for anti-fog for your car, right? Like this, what is it called, Windex or whatever it is, right? What it does when you have these anti-fog products, it makes a change from what is on the left to what it is on the right. What is on the left, right, is film condensation. That means the liquid, I keep thinking of water, but it can be any liquid. The liquid that goes on the surface spreads, right? Spreads with its surface tension, and all the droplets connect and become a film. And then this film rolls down. As you get to see there, that reminds you of a boundary layer. And sure enough, it's not that different than a boundary layer. With one exception. In the boundary layer, we say, is kind of insulating, right? But in this case, whatever went from vapor to liquid, right, is depositing all this latent heat, right? So this film, right, is absorbing all this latent heat that goes onto the plate, right? So this is a very common case. The other is the dropwise, is the one for which they sell you the product, same as in the anti-fog in your ski goggles, right? What you try to do is to have a non-wetting surface such that the droplets don't spread. They kind of stay as a droplet itself might even roll off. That would be ideal. So the droplets don't coalesce, they roll off, and in this case, you have a much enhanced heat transfer coefficient because you're in direct contact with the surface. For the same amount of condensation, more of this heat goes on the surface when it's dropwise than when it is film, right? It's about 10 times more. Now this is difficult to maintain because you need these special chemical treatments that would make it the droplets non-wetting, right? Whether it's Teflon or I forgot now the brand of those things that you put in your car and then you can never take out. It's silicone base. It's terrible, right? And same as after you wash your car, that they wax it and then you see all the droplets rolling off. That's what's happening, right? So look at this photo. In this photo, you have on the left, the dropways condensation. And on the right, you have the film condensation. This is the same experiment made on the same the same experiment made at the same time, but on the left you have it chemically treated with a non-wetting agent, the surface, and on the right you don't. So on the right there is a film, it just doesn't see, you don't see it. So about boiling and condensation, this is what I wanted to share with you. Do you guys have any questions about this? Okay. If you look at old exams, you'll see that we always ask a question typically related to the curve of boiling. But what we have discussed here, that goes. So this is good.